Good evening. Welcome, students. Welcome to Unacademy, largest online e-learning platform. Today, I'll be discussing Control System Engineering crash course for semester exams. This is useful for the students who are preparing for semester exams of Control System Engineering for electrical, electronics, and instrumentation engineering students. This session starts today and it is a crash course and it will be done in 10 to 12 hours. So this will be very much useful for you, those who are about to write your semester exams. Thank you for joining me. I'll just give you an introduction of mine. I'm Y. SRAVAN Kumar, having 7+ years of teaching experience and mentored more than 5,000 students for GATE and engineering services and qualified GATE and AIEEE, qualified GATE thrice. Thank you. So before getting into control system engineering subject and topics, let me explain you the process of Unacademy learning app installation and also subscription. You just need to get into Play Store and type Unacademy learning app. This is what the first step that you need to do, and you'll come with this installation process. Just click on this installation, and the step 3 will be, if you are opting for GATE and engineering services, click on this GATE and engineering services, and step 4 you have plus with a plus sign here. There is plus and iconic subscriptions. You can click on plus or iconic subscriptions. Then the step 5 is you need to get the subscription to this, and you can use my code as YSK10 to get 10% discount, and you have both plus and iconic subscriptions for GATE and engineering services. And when you get to payment, you have several options of either debit card, EMI, or UPI, and wallet or net banking payments. You can use any of these and you can get subscription to Unacademy. Now, why this semester exams pattern is given by the Unacademy? To get out of the phobia of semester exams, crash courses with each subject in a week. You can complete a subject in a week, and in this we'll be discussing answers to the previously asked questions. A detailed explanation of concept underlying the question will be discussed, and you'll crack your exams with good scores. And coming to control systems or control system engineering in some universities, you can follow these textbooks: Control Systems Principles and Design, Tata McGrail publications by M. Gopal, or Automatic Control System of Friends Hall of India, Q, and Modern Control Engineering by Ogata, or Modern Control Systems by Nagarath and Gopal. These are the textbooks and reference books for control systems or control system engineering. Then, what is a topic or what's the general syllabus of any of the universities in India of control systems or control system engineering is: you have introduction to control systems as your first chapter or unit. Then you'll have time response analysis, and stability analysis is your third part. Frequency response analysis, and the fifth one would be state space model. Okay, thank you. Yeah, let me know if some students who are watching, let me know please if my voice is audible and if the video is clear or not. Could you please let me know so that it will be helpful for me and you as well. So once again, I'd like to tell you the chapter wise uh, topics that are a part of control systems: introduction to control systems, time response analysis, stability analysis, frequency response analysis, and state space modeling. These are the concepts that we will be discussing in this crash course of control system engineering. All right, so everybody must concentrate, and whoever wants to clear your exams with good scores have to watch these lectures regularly. I'll be online live from 6:45 to 7:45 in the weekdays, and we'll also plan some marathon sessions if possible to give you some numericals that are frequently asked in your semester exams as well. Now, today I'll just give you a glimpse of Introduction to Control Systems Chapter 1, and let me tell you what are the basic topics that we have in this Introduction to Control Systems. You have what is a system and control system. We'll see what is a system as well as what is a control system. What are the different types of control systems? And in specific, we will see what is open and closed loop control system with examples. And we'll study transfer function of electrical and mechanical systems. Once again, we'll see what is a control system. What are the different types of control systems, and what are open and closed loop control systems, examples of open and closed loop control systems, and also differences between open and closed loop control system, wherein you will also come across something called as feedback. And also we will discuss transfer function of electrical and mechanical systems. In the next session, we will be discussing block diagram reduction technique and signal flow graph and Mason's gain formula. So these are the topics of Introduction to Control Systems Chapter 1 that I will discuss. So let's get one by one into these topics. Hope you people are able to understand. Sir, yes, sir, audible, visible, sir. Thank you. Yeah, this syllabus is common to all the university students. It's not particular to any of the university. It's a common syllabus that is available for all the students. Rohit, it's a common syllabus. You can R16, R15 as well, R13 for the students of JNTU Hyderabad, and as well as this is a common syllabus to the other universities of Madhya Pradesh, UP, and other states also. Control system engineering is a common syllabus throughout India. These five topics that we have seen, I'll just go back and tell you. So these five topics that I have discussed are common syllabus being followed by all the universities and colleges throughout India, particularly. So, what are the expected questions? Because we are discussing mostly about semester exams. So, what are the expected questions from this chapter 1? So, mostly in chapter 1, apart from the next lecture, the questions that are asked are explain open and closed loop systems with examples, or classify control systems, explain about mechanical translational and rotational systems, and some problems on these mechanical systems. Along with this, you will also have block diagram reduction technique, procedure, and problems based on them, as well as Mason's gain formula based signal flow graph method and problems based on them. Alright, so these are some of the expected questions you can see. So once again, I'll tell you what are the questions that are expected from this chapter 1. One is explain open loop closed loop system, classify the control systems with examples, explain about mechanical, translational, and rotational systems, and different types of problems on mechanical systems, block diagram, and signal flow graph. Sometimes you'll also be asked about state and explain Mason's gain formula. SVS online education training. Good evening, sir. Good evening. Good evening. So, system. Let's see what is a system and what is a control system. A system is a combination or an arrangement of a different physical components which act together as an entire unit to achieve a certain objective. So, a system can be an arrangement of different components. We'll call represent it as a box, and which has some task to be performed. We'll give some input to this and we will expect an output to this. We will get some output to this. And to control means to regulate or to direct or to command. Hence, a control system is the same as the arrangement of different physical components connected in such a manner so as to regulate, direct, or command itself or some other system. In this, we will command it, direct, or regulate the same system or some other system. Here, the difference between a system and a control system is a system has an output which may or may not be a desired output, but whereas in case of a control system, a system, if an input is given, the output is a desired output. So the basic difference between a system and a control system is a system is combination of arrangement, combination or an arrangement of different physical components which act together to get a certain objective, to meet a certain objective. And a control system is to command or regulate itself or any other systems. So hope you are clear with this system and a control system. Mahesh Kusuma, good evening. Good evening, sir. Good evening. So let's look at, good evening, Karthik. Let's look at the block diagram of control systems, a general block diagram. So a general block diagram of a control systems is represented something that's shown here. It has a controller, a plant, and a feedback element, and you have an input and the output. So this controller, this is a block of a controller block, and this block is a process or a plant, and you have an output and an input is given to this system. Here you'll have an error detector, and this is the feedback, a part of the output that is taken and given as the signal to the input combined with the input is called as a feedback. It is given through some feedback element. Always the feedback element is a measuring element. So this error detector will generate an error signal which is given as the input to this controller. Then this controller will generate an actuating signal to this process, and a desired output is obtained at the output. While writing in your exams, you can also write about each and every component here. You can write this input and about output and actuating signal, feedback elements, and everything. So this is a general block diagram of a control system. Nakesh Kumar, your voice is clear, sir. Thank you, sir. Now, let's see what is the classification of control systems. Classification of control systems can be based on hierarchy or based on the presence of human dependency, or it is depending on the presence of feedback. You can see here. So depending on hierarchy, you can classify depending on presence of human being, depending on presence of feedback or purpose of use, you can classify the control systems. Let's look at the classification one by one. If you are looking at the hierarchy, it can be classified as open loop control system or closed loop control system or adaptive and learning control system. And depending on presence of human being, it is either manually controlled control system or automatic controlled control system. And based on the feedback, you'll call it as a feedback or a feedback. It's one and the same as open loop and closed loop again. And depending upon the use of the purpose of use, you can classify as position control system, velocity, process, or temperature control system. And again, you can further classify these based on closed loop control systems, can be further classified based on time dependencies as time varying control system or invariant control systems, or based on method of analysis and design as linear and non-linear control systems, and causal and non-causal control systems. Based on the types of the signals, you can classify it as continuous and discrete control systems. And based on number of inputs that are given to the control systems, you can classify them as single input single output, multiple input multiple output, single input multiple output, or multiple input single output control systems. Maybe this will be looking a bit complex, but this is the total classification of a control systems, wherein you need not write all these classifications. You can take some of them and write the classifications. And based on the order of the differential equation also, you can classify as first order, second order. And based on number of open loop poles or poles of the transfer function as type 0 and type 1 control systems. Based on the prediction and repetition, you can call it as deterministic and stochastic classification. And based on the type of the damping, good explanation with examples. Thank you. So based on the type of the damping, you can classify as undamped, underdamped, critically damped, or overdamped control systems. So this is the classification. So majority of the times you will classify them as linear control systems and non-linear mostly, and continuous and discrete control systems, deterministic and stochastic control systems, causal and non-causal control system, and open loop and closed loop control systems. So these are the major classifications, and rest of them are the part of these things. So you can classify the control systems basically into these 5 categories. When you are asked in your exams, you can pick off these control system types, and you can explain about these different types of control systems. Now, the major classification of control systems is open loop and closed loop. Although you have different types of control systems as linear, non-linear, causal, non-causal, deterministic, stochastic, the major classification of control system is open and closed loop control systems, which is one of the important questions that is generally asked in your exams. So what is an open loop control system? An open loop control system is something like this, wherein you have a controller, a process, to which an input is given, and you will get some output according to the given input. In this, you do not have any feedback that is fed to the input. Although you can measure here, this measurement does not have effect on the input. So a system whose output does not have any effect on its input is generally termed as an open loop system. And it's not that if there is no feedback, it is an open loop system. No, an open loop system also has some feedback, or you can also measure the output, but the difference is that it is not taken into consideration, or it is not connected or given back to the input for error correction. Whereas in a closed loop control system, you have same controller, a process, to which an input is given to this particular system. This is forward path. We will call this as a forward path, and you'll get some output based on it, and you have some measuring elements, and based on this, you will give this to the input for error correction. You need to get some desired speed, which is not obtained, so you will just give back this to the desired response is not obtained, so you'll give that error to the input for correction. So the major difference between an open loop closed loop system is an open loop system feedback is not does not affect its input for error correction, whereas in a closed loop system the feedback is given as input again for error correction. So the basic examples of open loop, these are the examples of open loop, the left side that you see, and these are the examples of closed loop controls. This is one of the example of closed loop system. Also, you have many more. I've taken human being as an example of closed loop control system. And if you see an electric dryer, wherever you can, whenever you are into any movie, cine malls, or at your working place or somewhere, you have hot air outputs coming out of this long as you keep your hand under the machine, irrespective of how much your hand is dry, irrespective if you are even if it is very little dry, it is set such that it gives the hot air that's coming out of it for a specified amount of time. That means it is not considering the dryness of your hand. And similarly, if you see the bread toaster, the machine runs as per the adjusted time. Even the washing machine that you see, irrespective of your clothes, it will irrespective of the dirt of your clothes, it will run on a specified time that you give to that washing machine. And the bread toaster also does the same thing. This will run as per the time adjusted, irrespective of the toasting is completed or not. Even if it's completed or not, it doesn't matter. So these things which do not consider the desired output are considered to be an open loop system, and which does not take the exact output that has to be given. And on the other hand, if you look at the closed loop control system, the human being is one of the best examples of closed loop control system. The best example, as you can see, is a human being. If a person wants to reach for a book on a table, for example, I've taken this as an example. Position of the book is given as the reference. Feedback signal from eyes compares the actual position of the hands with the reference position, and error signal is given to brain, and brains manipulates this error and gives signal to the hand. This process continues till the position of hand gets achieved appropriately. Although this is done very quickly by us, you can just imagine what exactly is happening and very fast. Here, the brain will act as a controller. If you can see here, the brain will act as a controller. And Soumya Boshalli, good evening. Good evening, sir. Good evening. And the hands are acting like a process, and eyes are the feedback elements or feedback. And the reference is the position of the book, and the desired position of the hands is the output. Now, as I told you, if a person wants to reach a particular table, book on a table, position of the book is the reference, feedback signals from eyes, and compares the actual position of hands with the reference position. And this eyes will compare or generate the error signal, and it will send the signal to the brain. So the brain stimulates this error and gives signals to the hand. That means still there is some distance, or still there is some difference, or still there is an error to the difference between the hand and the book. So it has to still extend. So in this process, this will continue till the position of the hand gets achieved appropriately. So once again, you need to remember the controller here is your brain, and the process is the hands, and feedback is your eyes, and the reference position of the book is the input, and the desired position of the hands is the output. Yes, sir. Clear, Vijay Kumar. Thank you. Now let's see the differences between. This is one of the questions again, which is being frequently asked in your exams. What is the difference between open loop control system and closed loop control system, or differentiate or compare and contrast between open and closed loop control systems? As we have seen, in an open loop control system, the feedback element is absent. In a closed loop control system, the feedback element is always present. Now, in a open loop control system, error detector is not present because there is no error, there is no feedback that is given back to the input for error correction, so you do not have any error detector. Whereas coming to a closed loop control system, an error detector is always present because you have to have the better output. And because the error detector is absent and the output is same always, these systems are said to be stable systems, more stable systems, and closed loop systems may become unstable or can be made stable sometimes. Now, because open loop systems do not have any feedback elements and all, you can say these systems are easy to construct, and closed loop systems, because they have the feedback elements that are to be incorporated, these are a bit complicated, although we have seen a small system in the slides. But in a real time system, the feedback elements are much more complicated for constructional point of view, and these are economical because you don't have the other elements that are to be included in the constructional point of view. And here you need to incorporate error detector as well as the feedback elements, so it becomes a bit costly. And coming to this bandwidth, it has a very small bandwidth, open loop system, whereas a closed loop system has a larger bandwidth. And you know that because it's an open loop system, the output is, or it is an inaccurate system, because whatever the output that we have got, we have just put it same. We did not try to give feedback and change it in open loop systems, whereas in closed loop system, we try to give some feedback to get the desired output. And because as already told, this has less elements, so it needs less maintenance, whereas closed loop has more components, so it needs more maintenance. And as you all can see, open loop systems are unreliable and closed loop systems are always reliable. So can you tell me what are the examples of open loop systems again? Same, hair dryer, tea maker. And closed loop system, there are so many examples that you can give: servo voltage stabilizer, many other things that you can give as closed loop system, human beings, so many. So let's look at once again the open loop and closed loop system differences. The first one, the first one is feedback element is absent in open loop, and feedback element is always present in closed loop. Second is error detector is not present in open loop, and error detector is always present in a closed loop system. An open loop system is a stable one, and a closed loop system is can be unstable. And open loop systems are easy to construct, and closed loop systems are complicated in construction. And economical point of view, open loop systems are more economical than closed loop systems. And because these have very small bandwidth, these have very larger bandwidth. Open loop systems are inaccurate, whereas closed loop systems are accurate. Open loop systems require less maintenance, and closed loop systems require more maintenance. These are unreliable, and closed loop systems are reliable. And the examples are hair dryer, tea maker, toaster, washing machine are examples of open loop control systems, and servo stabilizer, human being, driverless cars, and so many other things are examples of closed loop control system. Hope this is clear for you. Open and closed loop control systems. Gopal Krishna Rao, very good explanation, sir. Thank you, Gopal Krishna. Now, let's see what are the advantages of open loop. Although we have seen the differences, the same would apply here. It is the simplicity and stability is one point which is advantageous. They are simpler in their layout and they are economical and stable too. And coming to constructional point of view, they are simple layout, so easier to construct. And what are the disadvantages? Accuracy and reliability is one disadvantage. Since these systems do not have any feedback mechanism, so they are less accurate, inaccurate, I can say. The result output, hence they are unreliable too. Due to absence of feedback mechanism, they are unable to remove the disturbances occurring from the external sources as well. So these are the advantages and disadvantages of open loop systems. We can also see what are the advantages and disadvantages of closed loop system as well. So accuracy is one advantage. They are more accurate than open loop systems due to complexity. They are equally accurate and not disturbed in presence of non-linearities also. And noise reduction ability is one good advantage of closed loop control system. Since they are composed of feedback mechanism, they clear out the errors between input and output signals, hence remains unaffected by the external noise sources. And what are the disadvantages? They are complex in construction, and since it consists of feedback loop, it may create oscillatory response sometimes, and these are less stable than open loop system. But the disadvantage can be striked off since we make the sensitivity of the system very small. We'll see what is the sensitivity also to make the system stable as possible. So these are the advantages and disadvantages of open and closed loop systems. Open loop system, closed loop system. Till now, what we have seen is, I'll just give you a quick review of what we have read till now, because we have been discussing some points. Maybe you must have lost the previous ones, those who have joined just now. We have seen what is a system and what is a control system. Then we have seen what are the different types of control systems, and the major classification was open and closed loop control system. We have seen some examples of them, as well as the comparison and advantages, also disadvantages of each. This is what we have seen till now. So you can expect one question from this. What are the different types of control systems? What is open loop control system? What is a closed loop control system? What are the examples of that? And what is the comparison between open and closed loop control systems? What are the advantages and disadvantages of open and closed loop control system? Next, we have been seeing the difference between open and closed loop control system was the feedback. So what is a feedback and what are the types of feedback? This is what is our next topic of interest. We have seen what is open loop and closed loop control system. The major difference between the open and closed loop control system was a part of the signal is fed back to the input in closed loop, whereas although we have the measuring devices at the output in open loop, we do not take that into consideration uh, to give it back to the input for error correction in open loop system. So feedback is the part of the signal that is taken back to the input for error correction, wherein you have an error detector which will detect the error between the desired response and the actual response. So there can be two types of feedbacks. So you have types of feedbacks, positive and negative feedback. This is other topic that is generally given, or almost some of the interviews you can also expect this question: what is the feedback and what are the different types of feedback and what are the advantages and disadvantages or characteristics of feedback element. So feedback is generally of two types. One is positive feedback, other one is negative feedback. Vasuchandra, it's good to see you on good platform, sir. Thank you for clear explanation. Thank you, Vasu. Thank you, Satish Kumar. Now, what is a negative feedback? What are the characteristics of these negative feedback? Uh, so, it has an increased accuracy, an increase in the system's ability to reproduce faithfully in output that which is dictated by the input, and a reduced sensitivity to disturbance when fluctuations in the relationship of the system of output to input caused by the changes within the system are reduced. The values of the system components change constantly throughout their lifetime. But by using the self correcting aspect of feedback, the effects of these changes can be minimized. So, this is reduced sensitivity to disturbance. We'll see what is positive and negative feedback as well, but because negative feedback is very important, I'm just giving you what are the basic characteristics of negative feedback, which is one of the important topics. What are the different characteristics of negative feedback is one question that is frequently asked. So instead of discussing what is positive and negative, just I've tried to give you what are the different characteristics. So first characteristic is increased accuracy. This is one good advantage of negative feedback. Increased accuracy. Next, reduced sensitivity to disturbances. Next, smoothing and filtering. So when the undesired effects of noise and distortion within the system are reduced, so you'll get smoothing and filtering as well. Then increased bandwidth. When the bandwidth of any system is defined as that range of frequencies or changes to input to which the system will respond satisfactorily. Now, before comparison between positive and negative feedback, I'll just give you. This is the error detector. I'm just drawing plant and controller. So you'll also have a controller at before this. There is an output that is, so a part of this output is fed back to the input. So this is the input. Input is represented as R of S, output C of S. The forward path or general open loop system is given as G of S, and feedback is written as H of S. If this feedback, a part of the output is taken back to the input, if it is in phase with the if it is in phase with the input, it is called as positive feedback. And if it is out of phase with the input, the feedback, it is called as the negative feedback. So generally, this positive feedback will have a response of oscillatory nature. It will increase the oscillations, and negative feedback will reduce the oscillations or the response of the system, which is desired one. So always we have so many advantages of this, as I told you. Because of this, negative feedback is much more preferred over positive feedback. Negative feedback is much preferred over positive feedback. So that's the reason we were studying, and in question papers also you'll mostly see what is a negative feedback and what are the different characteristics of negative feedback. Whenever you have a negative positive feedback, you should represent it by plus sign here, and if it is a negative feedback, you need to represent it by a minus sign here. Now let's compare this positive and negative feedback quickly. So you can see net input of the signal in case of a negative feedback. If you see comparison of negative and positive feedback, comparison of negative positive and negative feedback. So negative feedback is 180 out of phase, as I told you, with input signal, and positive feedback is in phase with the input signal. So if you compare these two, the net input signal, the net input signal decreases in case of a negative, and it increases in case of a positive, and the gain of the system will decrease in case of a negative feedback signal, and gain will increase in case of a positive feedback system. And the noise is reduced in negative feedback and it increases in positive feedback. And stability is improved in negative feedback and it is poor in positive feedback systems. And the uses of these negative and positive feedbacks you can see in amplifiers. Negative feedback is used, and in oscillators positive feedback is preferred or it is applicable. So these are the different aspects on which positive and negative feedbacks are compared, and with this you can see the most advantages of these two feedbacks would be the positive feedback where stability is improved, sorry, negative feedback where stability is improved and the noise is reduced. So this is an important feedback, negative feedback, which is generally applied for any system. In oscillators, positive feedback is used, but in most of the applications, negative feedback is much preferred over positive feedback. Now that was all about positive and negative feedback and feedback systems. You also have much more to learn about it, but being a crash course on control systems will not be getting in much deep into the subjects. So let's see the next one, mechanical systems. In this you have two types of mechanical systems. One is mechanical translational system and mechanical rotational system. I'll, I generally discuss about one example with everyone, with all my students. See, consider a train that's moving. See, most of the mechanical students will understand it very easily. Mechanical translational and mechanical rotational systems. Coming to electrical, electronics, and instrumentation students, this concept has to be explained with these examples, which are much more easier to understand. Let us consider a train that is moving. This train is moving, and there are two things that I want you to keep in mind. There is a movement of compartment of train, and there is a movement of wheels of train. Now if I ask you the movement of compartment, it is moving in a linear fashion or it is in a straight line. You can see it moves in a straight line. And if you look at the wheels will rotate. That means they are in rotational motion. So in most of the mechanical systems you have these two. One is mechanical translational system and the mechanical rotational system. We will discuss transfer function. We will derive transfer function to this mechanical as well as electrical systems. But before that, I will just tell you in simple terms what is transfer function. Now, what is a transfer function? A transfer function is Tharavat Krishna. Thank you. A transfer function is generally defined as Laplace transform of output of any system to Laplace transform of input to the system, where you'll have zero initial conditions. So this is a transfer function. Generally you can represent is a T of S. Let us take a control open loop control system which has G of S and R of S as the input and C of S as the output. Now C of S is the Laplace transform of output, R of S is the Laplace transform of input. Therefore, what is the transfer function? It is C of S by R of S. So this is the Laplace transform of output to Laplace transform of input, which is termed as transfer function. Transfer function. Sir, I'm Subhash from Shreyas College. I'm missing your lecture, sir. Thank you, Subhash. I'm live for you. You can join me on this and you can also listen to my lectures. Control Systems Crash Course every day, 6:45 to 7:45. Thank you, Subhash, for joining me today. Nice teaching, sir. Thank you. So T of S transfer function is equal to C of S by R of S. So we will have to find these transfer function. In your syllabus you need to find this transfer function for electrical systems, mechanical systems as a part of your syllabus, mechanical translational system, and mechanical rotational system also. As a part of your syllabus, we will find transfer function for all these systems. So before getting into mechanical system, I'll just take one example of an electrical system and try to tell you how to find. There can be a question like this: determine the transfer function for given electric circuit, or for the given circuit. The circuit can be something like this. Consider a RC circuit. So this is the circuit given, where he has given as V output here, this as C, this as R, this as I, and this as Vi. So the first step that you need to do in this is, first you need to see what is the input to the system and what is the output to the system. You need to write these two things as your first step. Input here is Vi, output is V0. So as a part of your syllabus, the solution has to be written as per your semester exams like this. First write what are the inputs and output, then write what is the transfer function. Transfer function T of S is equal to, what is it? Laplace transform of output to Laplace transform of input. So here you can write T of S is equal to Laplace transform of output is V output of S, because this is output, its Laplace transform will be V output of S. The Laplace transform of V input is V input of S, Laplace transform. So it is V output of S by V input of S. This is what is required. This is what you need to find. This is our task. So let us try to find this. So we need to find expressions for both V output and V input. This can be done in two ways. One is, you can convert the total network first into a Laplace domain and then start writing the equations. Or second, you can write the equations, differential equations or integral differential equations corresponding to this, and then apply Laplace transform. I'll directly write the Laplace transform. So the Laplace transform of Vi is Vi of S. If you are taking I, the Laplace transform will be capital I of S. R does not change, and capacitance, it is 1 by Cs. I'll also tell you what are the different Laplace transform of different electrical elements. So first apply KVL to this. So Vi of S is equal to R into I of S plus 1 by Cs into I of S. This is the input equation. Now if you apply KVL at the output, Ohm's law, V output of S, V output is also V output of S. V output is equal to 1 by Cs into I of S. Now let us consider these two as two equations. Call this equation as 1, call this equation as 2. If you divide 2 by 1, you will get the transfer function. So let us take this to the next slide. Now you have two equations. Our task is to find transfer function T of S. So it is V output of S by V input of S. What is V output of S? In this, you can take common I of S and write the equation as R plus 1 by Cs. So it is I of S into R plus 1 by Cs by it is I of S into 1 by Cs. So the transfer function T of S is equal to R plus 1 by Cs by 1 by Cs, which you can write it as, if you take LCM, RCS plus 1 by Cs by 1 by Cs. Right? So this will become the transfer function. This is how you will determine the transfer function of a electrical system. You can just simplify this, or you can also write till this point in your examination. You'll be given marks. So this is the transfer function of a RC series circuit that is given in the question. Likewise, you'll be given some question and you need to find the solution. The first thing that you have to understand is you need to first write what is the input of the system, what is the output of the system, write the transfer function, and for an electrical system you can apply mesh or nodal or KVL or KCL and get the equations, and finally write the transfer function. Finally write the transfer function V output of S by V input of S. Depending on the, this session is very useful for me. Thank you. So likewise, we'll also see what are the mechanical system, as I told you. Yeah, you have, we were discussing about mechanical system. You can expect one question on mechanical systems and electrical systems also sometimes. So I'll tell you what are the different mechanical, translational, rotational system, basic equations corresponding to this. No. First one, let us consider mechanical translational system. Mechanical translational system. What are the equations governing this? What are the elements of this? As I told you, for these mechanical translational system, you need to first know what is the input and what is the output of the system. Thank you. So then you will define what is the transfer function of the system. Now, for a mechanical translational system, let us consider a body, mass. To this mass will have some moment only if there is some applied force on it. Yes or no? Yes. due to this force, there will be some displacement. We'll denote it as x. Because I have denoted displacement, I will also define what is velocity. Velocity is equal to distance by time, and acceleration is equal to velocity by time, or you can also write in terms of rate of change of velocity as well. So the input here for a mechanical translational system is force, and the output is displacement. So what is transfer function T of s is equal to, you always have to write Laplace of output to Laplace of input. So you need to take the Laplace transform. Let us denote this force by F and displacement by X. So if you write Laplace transform to this, it is F of s, and the Laplace transform here is X of s. So what is the transfer function T of s is equal to X of s by F of s. So this is the transfer function corresponding to a mechanical translational system. Also, we'll see mechanical rotational system. Then we'll take up with few examples in the next session. So mechanical rotational system. So a mechanical rotational system will have a rotating part and you'll have some input and there is some output. Generally the input to this will be a torque and output is the angular displacement. So the transfer function corresponding to this will be theta of s by T of s, or capital T of s, you can denote it. So this is a transfer function corresponding to a mechanical system. We will continue this session, mechanical rotational and mechanical translational system, tomorrow. We'll take up some examples. Thank you all for joining me. Uh, we'll have this continuation of this session in the next class. So, as I always tell you, there is no shortcut for success. Your success, your future, your desire is in your hands. Never give up. We here are ready to help you for your success ahead. So, coming to this India's number one study channels on Unacademy, we have Creatrix for electrical EC and instrumentation gate, and Unacademy Gate for ME, PI, and XE students, Unacademy Gate CE, Unacademy Telugu Gate, and Unacademy SSC JE channel as well, Unacademy Computer Science channel as well. We also have Unacademy Gate Questions and Electrical Junction, Unacademy Engineering Foundations, and Unacademy Pathshala, along with Unacademy Semester Exams. You can subscribe to our channels, join us, and learn things for your achieving your goals. So you can also reach us on Telegram, https:/t.me/creatrix gate electrical gate triple E. And I thank you all for joining me today and request you to listen to my lectures as well. Thank you.